Today's lesson is on matrix transformations. There are a few different types of transformations. You have translations, reflections, rotations, and dilations. Translations are also commonly referred to as slides. Reflections, you are flipping the figure across some line. And then rotations, you're turning it about some fixed point. Also with transformations, you begin with what's called the pre-image. So if we have some type of polygon where A, B, and C are the vertices of the polygon, ABC would be the pre-image. Once we perform our transformation, we'll get our image with there's usually prime symbols on each one of the vertices in our image. So ABC is our pre-image. We perform the transformation and we get A prime, B prime, C prime as our image. Now we can use matrices to express the vertices of a polygon by writing the coordinates as a vertex matrix. When we write a set of coordinates as a vertex matrix, we put the x coordinates at the top and the y coordinates at the bottom. All vertex matrices will have two rows. First row being the x's, second row being the y coordinates. So if we were to write this relation, these set of ordered pairs, as a vertex matrix, we would have 1, 2 in the first column, 3, 4 in the second column, and 5, 6 in the third column. All right, so to perform the transformations, we're going to either add or subtract, multiply the matrices by a scalar, or multiply two matrices. For a translation, or horizontal shifts, if we're going to move the pre-image horizontally, what we're going to do is add to the x coordinates. So we're going to add some number to the top row of our vertex matrix. And then for vertical shifts, we're going to add to the y coordinates, or the bottom row of our vertex matrix. So in our first example, we've got the following matrix, and we want to translate that vertex matrix, which corresponds to the coordinates -2, 4, 0, 6, and 1, -1. We want to translate this pre-image 3 units up, and then, 3 units to the right, and then 2 units down. 3 units to the right and 2 units down. So we should have 3s in the top row of our second matrix. And then since we're going to shift it down 2 units, we want -2 in the bottom row of our matrix. When we add 3 to each one of the elements in our first row, we're going to get 1, 3, and 4. When we add -2 to each element in our bottom row, we're going to get 2, 4, and -3. For reflections, we're either going to be reflecting across the x-axis, reflecting across the y-axis, or reflecting across the line y equals x. All right, to perform each one of the reflections,
please go to your pickup spot. Ryan De La Rosa, please go to your pickup spot.
To perform the reflections, we're going to take each one of these matrices, depending on which reflection we're performing, and multiply it by our vertex matrix. So these matrices should appear first, and then we'll write our vertex matrix second. For example, if we have these coordinates written in vertex matrix, we're going to reflect it across the x-axis, y-axis, and the line y equals x. So the first thing, to reflect this pre-image across the x-axis, we're going to multiply the matrix 1, 0, 0, negative 1 to our vertex matrix. That will give us the following matrix in the first row and the following values in the second row. All right, so if we plotted these coordinates, the coordinate 1, negative 1, negative 1, 4, and negative 2, negative 4, that would be a reflection of the pre-image across the x-axis. For a reflection across the y-axis, we're going to multiply the negative 1, 0, 0, 1 matrix by our vertex matrix. When we do that, we'll get the following values in the top row and these values in the bottom row. This vertex matrix represents the reflection of our original pre-image across the y-axis. And then to reflect that same pre-image across the line y equals x, we're going to multiply it by the 0, 1, 1, 0 matrix. When we do that, in the top row, we're going to get 1, 4, 4. Bottom row, 1, negative 1, negative 2. Next is rotations. Just a new set of matrices that we're going to be doing the same thing that we did for the reflections. It's just different matrices that we're going to multiply our vertex matrix by. So for a 90-degree counterclockwise rotation, you'll multiply our vertex matrix by 0, 1, negative 1, 0. For a 180-degree rotation, negative 1, 0, 0, negative 1. And then for a 270-degree counterclockwise rotation, 0, negative 1, 1, 0. So the same vertex matrix as our pre-image, we're going to rotate it 90 degrees, 180, and 270 degrees counterclockwise. All right, so we start with the rotation, 90-degree rotation matrix, 0, 1, negative 1, 0. Multiply that by our vertex matrix. We get negative 1, negative 4, negative 4. And the second row, 1, negative 1, negative 2. For a 180-degree rotation, we're going to take the 180 rotation 180 matrix and multiply that by our vertex matrix. When we do that, we'll get negative 1, 1, and 2, negative 1, negative 4, negative 4. And then lastly, take the 270 matrix, 0, negative 1, 1, 0, and multiply that by our vertex matrix, and we get the following image for our vertex matrix. We get the following vertex matrix for our image. And lastly is dilations. To perform a dilation, we're simply multiplying our vertex matrix by a scalar. The scalar is the value that we're using to perform our dilation. So using the same vertex matrix as the previous examples, we want to dilate by a factor of 0.5. So we're going to multiply all the elements of our vertex matrix by 0.5. When we do that, we'll get 0.5, negative 0.5, and negative 1 for our first row. Second row is second row is 0.5, 2, and 2 for the second row.